Okay, let's take a look at some examples of how form in place gaskets have been used in the past.
One of our first and still most common applications for form and place gasketing is on handheld devices. If you ask any of the seasoned veterans at Chomerics, they'll tell you that these materials were basically formulated for cell phones because of crosstalk between the transmit and receive functions, and as a solution for sealing complex geometric areas. Chances are the cell phone in your pocket uses some kind of Chomerics form and place gasketing inside of it. The programmability and automation of form and place gasket means it's especially well suited for high volume applications. And although it was developed for telecommunication applications, it has become useful in many other industries.
Moving beyond cell phones and into missile applications, this material shows its diverse range of use. With the complexity of missiles and munitions these days, you have a lot of electrical components causing interference, such as GPS, antenna, and radar. Not only would this application see harsh environments, most missile housings have a special coating on the aluminum substrate that need that best shielding combined with the best adhesion properties. Failure is not an option in missiles, and the use of precise bead and shielding properties of the COFORM 5513 stepped up to the challenge here.
One of our highest volume applications over the last several years was an automotive sensor application that required tough standards such as zero defects, high shielding, and low cost. If you think about the advanced features in modern cars, such as detection, adaptive cruise control, blind spot detection, and autonomous driving, each system has an individual control and sensor housing. With Comeric's large material portfolio and integrated assembly capabilities, we were able to mold the plastic housing, spray it with a conductive copper paint, add a dispensed thermal interface material, and then dispense a form and place gasket in two places, as you can see here. We completed the main housing and shipped the box to the customer, where they simply inserted their circuit card and in turn shipped to their end customer for final installation on the vehicle.
Now, this application was for a life saving medical defibrillator, pretty much the same one you would see on the wall at the airport. The small form factor size of the form in place gasket was one of the key attributes that sold the customer on this technology. They had very thin walls along their ledge because originally it was a machined metal board shield and they had machined away all their metal to save weight. So it needed to be lightweight and reworkable. Those were their requirements. So we convinced them to convert their metal board shield into a conductive plastic housing, and then we dispensed the form in place gasket along the outside perimeter and through a cross member in the center for that cavity to cavity isolation. It was then attached with a few screws to hold it in place because of the reworkability, rather than trying to glue it down permanently with a conductive adhesive or even soldering a can in place. And as we end the presentation, we wanted to highlight a list of Parker Comeric's form in place materials. Please note the last two materials are non-electrically conductive, but there are various materials to choose from. So Ben, I've listened to this webinar and I'm thinking I have an application where form in place is going to work well. What are my next steps?
The first step is to run the design by our application engineering department. And once that's blessed, we can arrange some prototypes to be dispensed for your engineering evaluation. Comerix has capabilities to run high volumes, but we also have smaller machines for low volume runs, as well as several authorized distributors located around the United States, Europe, and Asia who can support programs of various sizes.